Hey geometry team, and welcome to Unit 8, Day 1. We are beginning our unit on circles. And so we're going to start today with just the very basics of your vocabulary that's going to cover kind of all the parts of circles, all the things you did know, didn't want to know, and need to know. So to start off with, what is a circle? A circle is going to be the set of all points that are equidistant, that are all the same distance from a given point. So I pick some point. I'm going to call that the center of my circle. The circle itself is every point that is the same distance away from that. And so you find any point that's a set distance away from here and you've created a circle. Now notice, the circle is actually only this black curve. It does not include the space inside. That's a circular space and we do all sorts of fun stuff with that. But the circle itself is only this rim. So please notice, your center is the point that is the same distance from all the pieces of the circle. The circle is the black curve that is equidistant from your center. All this white stuff here in the middle, that's not circle. That's just space inside your circle or outside your circle, okay? So keep it straight. Don't let people confuse you on that. So to name a circle, well, the one thing that is fixed in a circle is going to be its center point. So we name a circle using the center point. So you go, okay, the center of this guy is point P, then by golly, I'm calling this guy circle P. And you can do this little tiny circle with a dot in it to kind of make a shorter symbol for circle P, or you can just write circle P. Sometimes people get lazy and try and just put the letter, but that doesn't tell you if it's a point or if it's a circle. So instead of that, always label it either circle P or do a circle with a dot to let us know you're talking about a circle and not just a point. Okay, come on, buddy. Computer doesn't want to wake up today. So when you have that circle, this round curve here, we're going to start drawing a bunch of lines and segments all over it. And so when we do that, we give them a bunch of names. If you take a segment and put its endpoints on the center and somewhere on the circle, we call that the radius. So the endpoints are on the circle. It could be here. It could be here. Okay? It's called your radius. Sometimes people use the word radius to say the distance from here to here or the length of the radius. That's totally fine. You're just going to have to keep straight when you hear the word radius. Am I talking about the actual segment, the radius, or am I talking about the length of the radius or the distance the radius covers? It's interchangeable. We use it for both. Fun fact, the plural of radius is radii with a double I. And so if you have more than one of them, you say radii, not radiuses. Okay? Then we connect all the way across through the center. So this purple guy here, come on. There. So if you have a segment that has both of its endpoints on the rim of the circle and it cuts through the middle, this is called your diameter. And most of you have heard that one before. The main thing is that it has to go through the center of the circle to be a diameter. And a diameter is often, again, some people talk about the length of the diameter and call it diameter. Same thing, it's interchangeable. You can either use it for the piece or for the length of the piece. Okay? This guy, a chord, it has its endpoints on the circle as well. But since it doesn't go through the center, we don't call it a diameter. Instead, we just call it a chord. Okay, so you've got your chord that just has its endpoints on the circle. So those of you who are in music are perking up because, yeah, chords in music have to do with the sounds of the notes. And back when they were first making music, they had harps and things with strings. The lengths of the strings had to do with the sound. It's all interconnected. Okay, but here we just have a chord, endpoints on the circle. Over here now, let's look at this green fellow here. So this green guy here is called a secant, not second. We don't want to mix it up with time. This is a secant. And so a secant is going to be a line or a segment that touches the circle in 2 points, but it also goes outside the circle. So if you recall your chord, it had its endpoints on the circle, so it touched in 2 points, but then it stops. So a chord stays completely inside the circle. A secant can go outside the circle. So it still touches it in two places, but then at least one part of it is going to extend out beyond your circle. So secants think they're special. Okay? This blue line or segment is called a tangent. Tangents are completely outside the circle. They never go onto the interior. Instead, they swing by and they touch the circle in exactly one spot and then keep on going. This is called your tangent. So if you've heard the phrase going off on a tangent, that's because you're going along having your conversation just fine, but then you go off on here on that tangent line and suddenly you're no longer within the circle of your conversation. See, it all connects. This point where the tangent touches the circle is called your point of tangency. Ooh, ah, you're very thrilled. Okay, so looking at all this again, we've got some fun facts about all of these things. So fun fact number 1, if it'll wake up, there it is that a diameter is actually just a special kind of chord. Chords have their endpoints on the circle. A diameter has its endpoints on the circle. The diameter just happens to be a chord that goes through the middle. So we use diameter when we're talking about the diameter so that we know that it's going through the center. If we just say chord, then you know it's not going through the center. Okay? Fun fact number 2. A chord is just a smaller section of a secant. A secant goes outside the circle. A chord is the piece of the secant that ends on the edge of the circle. So if you take a secant and cut off the ends, you have a chord. And so you have to pay attention to what you are discussing. Is like, is this a chord? Am I talking about just the part on the inside, or am I talking about the whole thing? Okay? Oh, but there's more fun facts. There's always fun facts to be had in math. A diameter is actually made up of 2 radii that are pointed opposite each other. So right here, I go from the center to the edge, that's a radius. And center to edge, that's a radius. Together, if they form a linear pair, so they make a 180-degree line, that is a diameter. Some of you knew that, some of you didn't, but it has to be a linear pair of radii to create a diameter. Surely there's more fun facts. Oh yes, this tangent right here, it touches the circle at the point of tangency. If you draw a diameter or a radius to that point, it's always going to make a right angle. Any other segment that you could draw, any other chord or secant, that's not going to make a right angle with your tangent line. Okay, it's going to be some other goofy angle. But the diameters and radii are always going to form a right angle to your tangent at that point of tangency. So we've talked about all of these things. Now we're going to talk about arcs. Arcs are the actual pieces of the circle, these curved rims that come off here. And to find those rims, they are cut off or intercepted by angles. So this angle comes up here and chops off this piece. That gives me an arc. So these central angles that come from the center are angles, they're vertexes right at the center. They are the things that help us cut off our arcs. Okay? Now, if you have an arc that is cut off by an angle less than 180 degrees, we call this a minor arc. So it connects 2 points on a circle, and the angle made of those 2 points is less than 180. This is called a minor arc right here. Well, there's more than one minor arc in the picture. This angle, this central angle right here is 160 degrees. So this is also a minor arc. So anytime you have a central angle less than 180, it's going to cut off an arc that is a minor arc. Miss Cerna, what if it cuts off half a circle? These 2 minor arcs together cut a 180-degree angle. What happens there? Aha! In that case, we've done half the circle, so we call that a semicircle. And all it is this curved arc that is included by the diameter. So if the endpoints are the diameter, you've got yourself a semicircle. It's 180 degrees. Okay? The major arcs now, got to guess? These are going to be anything bigger than 180 degrees. And you might be confused asking, how can you have an angle bigger than 180? So here I've got my 120 degree angle. That means everything else here, this angle right here, this reflex angle, that is going to be 340 degrees of angle. That's a big old angle. Then this arc that is intercepted by that 340 degree angle is called a major arc because it is majorly big. Now the trick is when we name these, we need to be able to tell them apart. So we have this minor arc here, and its endpoints are on A and D. And then we have this major arc here, and its endpoints are also at A and D. So to name them and be able to tell them apart, we always name the minor arcs with 2 letters. So arc here, its endpoints are at A and D, so I would call this arc AD. And we use this curved little eyebrow to label it as an arc. This other arc, this major arc that goes from A to D, it still starts at A. I'm going to switch colors so I match the color of my arc. I start at A. I go all the way around to D, but since I'm a major arc, I'm going to make sure to have a letter somewhere in between here to tell me, hey, from A to D, I need to go through another letter. So I think we'll call it H. So arc AHD is going to be the arc that goes from A through H and then ends up at D. So from A through H and ends up at D. Now, could I have used the letter C here? Absolutely. I still start at A, I still go around this way, and I still end up at D. So it can be any point in between. Just make sure for major arcs and semicircles, always use 3 letters. Your start, somewhere in the middle, and your end. For minor arcs, we just go directly from them. Now, what if there's a point in between? What if I've got point K there? Well, since I know that this is a minor arc, I'm not going to use the letter K in the name. I'm still going to do a minor arc with just its endpoints, A and D. Okay? So just keep that in mind. Some stuff to keep straight so we all know exactly what we're talking about when we're naming the arcs and angles of a circle. Okay? So, here's an example. What is the measure of arc AC? So arc AC is going to be right here. And I want to know how we're going to measure that. And so what we do is we say, okay, that's a piece of this whole circle. And all these angles here in the middle add up to 360 degrees. And so we're going to say that the whole circle has 360 degrees on it as well. And so each arc is going to match the measure of the central angle that includes it. So if I were to say that this central angle here is 55, this little red dude is 55, then we're going to say that arc AC that is cut off by this angle is also 55 degrees. So the measure of the angle, so the measure of angle AOC is going to equal and tell me the measure of my arc AC. All right? And again, here's how we show the measure of the arc. We put the M in front of it, just like we did for angles. So if we're talking about a number, we use the M's in front for measure, and we use the equal sign. If you're just saying that arc AC is congruent to some other arc, and I don't know what other arc it might be, then you would use congruent. But when we're talking about the numbers of degrees, that's when we use equals. That's when we use the M's to remind us that it's a measure that we're talking about. All right? So, giving an example problem, if it will wake up. There it is. It's awake. So I want to know what is the measure of arc AD. So here's arc AD, right here. Well, I don't know how big any of the other arcs in the circle are. I know the whole thing's 360, but I don't know anything about this. So I'm going to focus on my central angles to tell me how big my arcs are. So this arc right here is 150 degrees. and this angle is 150. If I could figure out the central angle x, then I would know that whatever number of degrees this x angle is will be the number of degrees in my arc. So if I know that this is a 150 degree angle here, and this is a linear pair, then I can use the fact that those are supplementary to figure out what I've got. So x plus 150 is 180. Do my algebra, this angle x has to be 30 degrees. Well, if the central angle is 30 degrees, that means my arc AD is also going to be 30 degrees. Okay? I know it's all quiet and you're panicked, but we're not done. We have that reminder that all the central angles in a circle sum to 360 degrees, which means that the entire circle of arcs all also sum to 360 degrees. So, thank you for being part of this lesson. Good luck, and we'll see you for our next